All right, so we're going to be mostly covering learning target 5.3, which is factoring by GCF in this video, though there will also be some review of some other concepts. So let's go ahead and go here. We have some X game problems here to sort of warm us up. Feel free to pause the video at this point and try these problems if you want to. I'm going to go ahead and start solving them. So remember, with the X Games problems, their setup is we are looking for two numbers that multiply to this. So multiply to 40 in this case. And then they are going to add to the bottom here. They're going to add to 14. So the way that we solve these problems is we use a factor sheet. And we look at all of the factor pairs that are going to multiply and give us 40. And then we examine those factor pairs and we figure out which pair is going to correctly give us this sum adding to 14. So we run through the list, right? 1 plus 40, that's 41. That doesn't work. 2 plus 20, that's 22. That also doesn't work, right? 4 plus 10, there we go. That's the one we're looking for. 4 plus 10 gives us this correct sum of 14. So the solution to our X game problem is positive 4 and positive 10. Pretty straightforward, especially when we're dealing with only positive numbers. Then moving on to this next one, same ideas that are going on. We're still multiplying to the top and adding to the bottom. So it's still multiply and add. However, there's some negative numbers here, and this is where things get a little bit trickier. So whenever your product, what you're multiplying is negative, that means that you have a positive number times a negative number. Or we could switch that, a negative times a positive. So one of the two numbers that solves our X game is going to be a positive, and one of our numbers is going to be a negative. That's really all that's going on here. And then those two numbers will need to add together to be -1. That does increase the number of sort of choices that we have here, right? So if we're not just dealing with positives. So let's just run through it. We could have -1 and positive 56. We could have -2 and positive 28. We could have -4 and positive 14. We could have -7 and positive 8. Or we can switch those. We could have 1 times -56, 2 times -28, 4 times -14, and 7 times -8. So those are kind of more options that are going on here. Yeah, so we have to go through these and figure out which of these are going to give us the correct sum, although there are some ways for us to sort of help in this. We don't have to necessarily test all of these, right? It should be pretty obvious that some of these are not going to add to be -1, right? This right here, -1 and 56, no, obviously not. Obviously not. These are going to be like 55 and -55. That doesn't work. That's not what we're looking for. Here we're going to, if we added those together, we would get 28 minus 2, so we'd get 26. And this one would give us -26. There's kind of a pattern here, right? This is giving us 55 and -55 when we add them together. This one's giving us 26 and -26. So you notice they're kind of giving us the same number, but one's positive, one's negative when we add them. This is our adding column. Okay. Let's keep going through these right here. -4 and 10, or sorry, -4 and 14 give us 10. That's not right. And then 4 and -14 give us -10. Again, notice same number, one's positive, one's negative. So one of these has to be the solution. That's just the way that it works. Right here, when we add these together, we get 1. Ooh, that's really close, not quite the right answer. And then this one here will give us -1. So that's what we were looking for. We were looking for 7 and -8. Sometimes you got to run through them all. Again, if you had a little bit of a better idea of where to start, you might have decided to start down here with these ones where you thought they might work out, rather than kind of running through all of your options. All right, and then the last one, this is kind of the last type of these problems that exist, where we have a positive on top and a negative on the bottom. In this way, we need to think and remember that there are two ways for us to multiply. Remember, this is multiplication, and get a positive number. I can do a positive number times a positive number. I can also do a negative number times a negative number. Negative times negative will also give me a positive. But when I add these two numbers together, I get a negative. I get the correct sum actually in this first case. So those are going to be my solutions to this one. Two negative numbers, again, they multiply to be positive and they add to be negative. So that's what we're looking for. So in this case where we have a positive multiplication, a negative addition, we know we're looking for two negative numbers. All right, hopefully that reviewed the X game type problems there with you. Let's go ahead and move forward. Reminder about quizzes, if you're watching this and you're missing out on quizzes, make sure you catch up on those as soon as you can. All right, so we did the review of X games. I also want to talk about GCF and then what we touched on at the end of last week, factoring by GCF. This is going to be our main topic for this video. This is what we're calling Learning Target 5.3, factoring these binomials by taking out a monomial GCF. But let's first remember GCF. So let's look at these here. Find the GCF. When I say GCF, hopefully we remember, but if not, I'm talking about the greatest common factor. So I have these entries from our factoring sheet that can sort of help us answer these questions. We want to know what's the biggest factor that they have in common, that they both have. So let's just go through these lists. We're looking for 32 and 56. So here's our factor sheet entries for those. They both have 1, so this is a common factor of 1. They both have 2, common factor of 2 also. They have 4, so 4. We're working our way up. They do both have 8. They both have 8. No, 16 is not a common factor. 32 is not a common factor. So these are our common factors. We are looking for the greatest one, 8. So we say that our GCF here is 8. Not too difficult. We didn't need to circle all these and list all these. We could have just sort of looked at them and found this number, but I just wanted to go through my thinking there. And then the next one, we have 33 and 49. Fortunately for us, these don't have very many factors, so we can just sort of look at it. They both have 1. All numbers will have a common factor of 1, because you can always, every number is 1 times itself, whatever the number is. So they'll always have a common factor of 1. All right, so they have a common factor of 1. What else? 3 here, no 3. 11 here, no 11. 33 and no 33. And yeah, so 1 is the only common factor. It's fine. GCF is 1. Sometimes that's it. That's all they might have in common. All right. That's hopefully kind of reminding you the ideas of greatest common factor. And let's move forward. We're going to keep using this idea of greatest common factor. We're going to be factoring out a monomial using GCF. So what we mean by monomial, we mean a single term. We're going to be taking a single term out of this binomial expression, right? This is 2 terms. We're going to be taking something out. This is going to be our monomial that we factor away. We find what they have in common and we take it out of there. The way we start this is we look at our 2 terms here and we try to identify the GCF. There's 2 parts to this. There's the number part and then there's the variable part. So let's first focus on the number part. So 10 and 35, we have our nice factor sheet entry here. Those 2 numbers have a common factor of 5. That's the biggest one they both have. So our GCF is 5. And then as a second piece, we need to look at the variables. The variables are also part of our GCF. We want to decide, do they both have x's, and how many x's do they have in common? Well, this one has x to the 2nd power, which means x times x. This one only has a single x. So when I look at it, both of these terms have a single x in common. They both have at least 1 x. So that x is going to be part of our GCF. All right. What we're going to do here is we're going to be using an area model to help us factor this. So this is sort of like the reverse process that we learned in like week 9 and 10, where we were taking a monomial times a binomial and ending up with something like this. We're going to be starting with this and changing it into a monomial times a binomial. So we're going to put the this thing right here, our original problem, into the box. So 10x squared plus 35x. And then we're going to be looking for the numbers on the outside of our box. So we're going to be looking for these numbers on the outside. I'm going to erase some of this stuff just to make sure I have space. The thing that goes here, the monomial here, is the GCF that we found. What did they have in common? What could I take away from both of those things? And so we found that to be 5x. 5 was the number that they had in common as a factor, and x because they both have x's in them. Now what we need to do is a little bit of problem solving. We need to figure out the numbers that were on top, right? So 5x times what is going to give us 10? There's 10x squared. There's two pieces here. There's the number part. 5 times what is 10? That's going to be 2, right? 5 times what is equal to 10? Well, we obviously find that that's 2. And then I have an x here and an x squared here. How am I going to get x squared? Well, I need another x. That's the way I get x squared. I need another x up there to make that x squared. X times x is x squared. And I kind of move over to this part here. Same idea. 5 times what is going to give me 35? Well, thinking about that, 5 times 7 is 35. I need to have a 7 there. And then, okay, I have an x here. I already have accounted for my x. My x is already here. I'm going to give it an x by this. If I had another x up here, then this would be x squared. So this one's not going to have an x with it. And this is going to be our answer. So these two things right here are going to go together to be our answer. This is going to be the factored form of this expression. And so it is a monomial, the GCF, times this binomial that we ended up with on top, 2x plus 7. This process of factoring is somewhat complicated. We're going to keep working at it over the next few weeks. We're going to see several more examples here today. So let me go ahead and clear this work off. Again, this is our answer. This is the factored form. Let's go and clear this, and let's try a few more. All right, so again, this is target 5.3. I can factor out a monomial using GCF. So you can see here, I have kind of created this structure. I've already drawn out our area model, put some circles here where we're gonna come out with our answer away from that original problem. I'm gonna try to follow these steps as sort of a procedure for solving this factoring type problem. So the first thing I'm gonna do is I'm gonna put my binomial, so my original binomial, I'm gonna put that in the area model. 12x minus 9. Perfect, not too difficult there, right? The next part I'm going to do is I'm going to identify the GCF of my numbers. So I'm going to be identifying the GCF between 12 and 9. Luckily for me, I have this factor sheet entry right up here, but if not, we could just open up a factor sheet and try to find this GCF. They have 1 in common, so that's 1. They have 3 in common, and no 9. So 3 looks to be our GCF. 3. The next part here is the variables. So when you're looking at your binomial, what you're trying to factor here, you want to see if they both have x's or not. In this case, they do not. Only one of our terms has an x in it, so they do not have that in common. So we will not have an x as part of our GCF. It's just going to be 3. And that 3 is what goes on the outside. This is our GCF. It is the common factor between these two terms. All right. Again, there's no x with this because these do not have an x in common. Only one of the terms has an x with it. All right. And then to finish this problem off, what we need to do is figure out these numbers that are going to go on the top of our area model. Remember, the area model works in such a way that the numbers on the outside multiply to give us the numbers on the inside. So we have 3 times something. 3 times something is giving us 12x. So 3 times 4 is going to give us 12. And then how do we get this x? The only way to get this x is if this has an x. Remember, we already decided this does not have an x here because, well, there's not an x in both of these things, so there can't be an x here. So the x has to be on top. And then I answer myself the same question again, same idea here. I'm doing 3 times something to give me -9. So 3 times something to equal -9. So thinking about it, I definitely need this to be negative because a positive times a negative is going to give me negative. And then 3 times 3 is 9. So -3 is the number we're looking for up there. All right, let's go ahead and clear some of this off down here so we can write out our final answer, our factored form. So this is, again, what we call the factored form, and it's the answer of our factoring process. So our factored form here is going to be 3. That is our monomial times 4x minus 3. Again, this is sort of going backwards. We, in the past, in like week 9 and 10, we were starting with something like this, and we were using this area model to get the answer on the inside. We're going backwards. We're starting on the inside, and we're figuring out the numbers that were on the outside. All right, but again, that is our answer, that factored form right there. Let's go ahead and clear this off. We're going to do another example here together. All right, so let's take a look at it. This is the binomial that we're going to be factoring. So I'm going to try to follow those same steps. I'm going to just write it in my box. So -24x squared plus 30x. The next step is I need to identify the GCF. So I need to figure out what numbers these have in common as factors, 24 and 30. Again, luckily for me, I went ahead and put this up here. So 24 and 30, so they have 1 in common, 2 in common, 3 in common, 6 in common. I think that might be the biggest. 10 no, 15 no, 30 no. So 6 is my greatest common factor as far as the numbers go. Then I need to take a look at my variables. So again, notice here, I have x's for both of these terms. I have x squared, which is x times x, and I have x. So each of these have at least one x, so they have a single x in common, so we'll put a single x with our GCF. So now we've figured out both parts of our GCF. We found the number, and we found if they had a variable in common, which they do. So we write that right over here. Here is where we always put our GCF. It's the one number that they have in common. And then we need to figure out these numbers that go on top. So again, we remember the area model works this way. These two things come together to multiply to give me this. So I have 6x times something is giving me -24x squared. So there's a couple things going on here. I have 6 times some other number to give me -24. I can figure that out to be -4, right? I need to get that negative somehow, so this number has to be negative. And 6 times 4 is 24. And then I have to get that x squared. Right now I only have a single x, so that's not enough to get x squared. So this one also has to have an x, so -4x. That's how I'm getting that x squared, x times x. And then the next one, same concept here. We're multiplying 6x times something, whatever this number is on top, to get 30x. So 6 times 5 is going to give me 30. And then x, I've already accounted for my single x here. So this one does not have an x with it, because if it did, this would be x squared, which it is not. So this is just 5, positive 5. And from there, we have completed our factoring. We're done. You can check it. You can make sure that it does work out. 6x times -4x, make sure that we do get that product. 6x times 5, make sure that works. As long as all these things work, we have done our factoring correctly. And then here's our answer. 6x times -4x plus 5. This is our answer. This is the factored form of that original binomial. So this original binomial is equal to this. These two things are equal. They are just different forms of the same thing. Go ahead and clear that. And we will do 2 more here. 2 more, and then we'll end the video. So feel free to pause it and give this a try on your own. So this is a you try it in class. I'll have you guys try it. But for right now, I'm going to go ahead and do these in just a moment. So what I want you to notice about these two problems right off is this one, variables. They do not both have variables, so I won't have a common variable when I'm factoring. Whereas on this one, notice they do both have variables, so I will have a common variable. Kind of two different problems. Other than that, they're very, very similar. All right, let's start with this one. We'll just call this one number one, our first one. So again, write it in the box. It's not necessary that this is absolutely the first thing you do. You could start finding the GCF first if that's what you want to do, but whatever. So we're looking for GCF between 6x and 14, or minus 14. So here are our factors. Looks like 2 is the biggest factor that both of those have. They don't share any others that are bigger than that. So 2. And then, I said this before, but this one has an x, but this one does not have an x, so they do not have an x in common. So the only thing we have for our GCF is 2. Again, there's no x's in common, so 2 is our only GCF here. And then again, we have to kind of answer those puzzles for ourselves here, right? 2 times what is going to give us 6x? 2 times 3 is going to give us 6. And then where do we get this x from? If it's not here, it has to go here. We already decided it's not here because there's no x in common, so it's got to go up there. Same concept here. 2 times what is going to give us negative 14? Well, this has got to be negative if I'm going to get a negative here, right? Positive times negative gives us that negative. 2 times 7 is going to give us 14. And there we go. That's going to be our answer. 2 times 3x minus 7. These are not terribly difficult, okay? They take some time to get to this proficiency, but not terribly difficult. All right, let's go ahead and do our last one here together. Hopefully you've already tried this. If not, if you want to jump ahead, again, pause and try to do it on your own. I'm going to go ahead and go through it. All right, writing it in my box, in my area model. Okay, what do they have in common? What is my common factor? So 15 and 18. Looks like 3. I want to make sure it's the biggest one. It is, but double check, make sure that is the biggest factor. So right here, my GCF is 3. But what about the variables? Do they have a variable in common? They do. They both have x's. This one has 2 of them because of our exponent. This one has 1 of them. So they have 1 in common. So 3x. So 3x is my GCF. That's going to go down here. I always put that GCF right there. I'm factoring that out. That's my monomial that comes out. And now I need to figure out these things. Again, I'm kind of asking myself some questions to get these values. I'm asking 3x times what is going to give me 15x squared. You can write them out if that helps you. So 3 times 5 is going to give me 15. X times x is going to give me x squared. All right, if I have x squared here, both of these got to have some x's with them. So x. 3 times 5 is 15. They should be pretty easy if you're breaking it down in that way. Next entry over here, we're doing 3x times something to give us 18x. Our x is already accounted for, but 18, how do we get 18? 3 times 6 is going to give us 18. All right, and that's going to be our answer. We're finished that out. You can double check and make sure it does multiply out correctly, but it does in this case. So here is our factored form. 3x times 5x plus 6. There we go. All right, make sure you do the Delta Math assignment. Let me just undo that. Make sure you do the Delta Math assignment for this week, week 12 Delta Math, and also the quiz. See you guys in class.